Machine learning. You hear the term everywhere, right? It's the engine behind your spam filter, your streaming recommendations, even self-driving cars. It is powerful, it's everywhere, and let's be honest, it can feel like a total black box. Well, today, we're going to pry that box open. Over the next few minutes, we are taking a journey into what machine learning really is and how it actually, truly works. Okay, let's dive in. So to really get what makes machine learning so different, let's look at a super simple example, a spam folder. The old school way, which you see on the left, was to write a ton of explicit rules, like if an email contains for you, block it. Simple enough. But what happens when spammers get a little clever and start writing for you instead? Well, you have to go in and write another rule. It's a never-ending game of cat and mouse. Now look at the right side. The machine learning approach doesn't need all those handwritten rules. Instead, it just learns from thousands and thousands of examples of what spam looks like and what it doesn't. It automatically figures out, hey, this for you thing is a new spammy pattern, and it adapts. All by itself. That adaptability, that's the magic.
And that really brings us to the core question of this whole explainer. I mean, it's one thing to follow a command somebody gives you. It's something else entirely to figure out the command for yourself. So how on earth does a machine make that leap from just following instructions to genuine learning?
Well, the answer isn't magic. It's actually a process, a really structured, repeatable journey that can take you all the way from a fuzzy problem to a predictive model.
And here is our roadmap for that journey. You know, pretty much every single machine learning project follows these 4 basic steps. First, you have to study the data. Then you select a model. Step 3, you train that model. And finally, you use your trained model to make predictions on brand new data, which is a process that we call inference. We're going to walk through this exact life cycle to see how all the pieces fit together.
So, first things first, everything, and I mean everything, begins with the data. This is the raw ingredient, the textbook from which the machine is going to learn. The quality of your data, the type of data you have, it determines everything that comes next.
Okay, so the most common type of machine learning you'll hear about is called supervised learning. The best way to think about this is like a student who's studying for a test with the teacher's answer key right in front of them. The machine gets a whole bunch of data that's already labeled with the correct answers. For example, thousands of pictures, each one already tagged as cat, dog, or fish. The model's job is to study all these correct examples and figure out the general rules for telling them apart on its own.
But, right, what if you don't have an answer key? What if your data is just this huge, messy, unlabeled pile? Well, that's where unsupervised learning comes in. In this case, the machine is more like an explorer, trying to find patterns without any map to guide it. For instance, it could sift through all the visitors to a blog and just automatically discover different groups. It might find, say, sci-fi fans who visit on the weekends and comic book lovers who only show up at night, without anyone ever telling it those groups even existed in the first place.
So, let's just boil it down to the key difference here. On one hand, you have supervised learning, which uses labeled data to predict an outcome you already know you're looking for, like identifying a cat. On the other hand, you have unsupervised learning, which uses unlabeled data to discover hidden patterns you might not even know are there. Okay, so we've got our data, we know what kind of learning we're doing. Now we get to the heart of the journey, actually training the model. This is where the learning happens. So how does it learn? Well, you can think of it like a really, really smart game of trial and error. Imagine you're tuning an old radio. The model makes a guess, and something called a cost function basically tells it how much static there is, how wrong its guess was. The whole goal of training is to just keep tweaking the model's internal dials, its parameters, over and over until you get the clearest possible signal, which means the lowest possible error. Now, this whole process of minimizing error, of turning the dials, it sounds pretty straightforward, right? But there is a massive, massive trap that every single machine learning practitioner has to avoid. You could even call it the main villain of our story.
And this quote just perfectly nails the problem. It's a phenomenon called overfitting. It's what happens when your model learns the training data too well. It doesn't just learn the important patterns, it also memorizes all the random noise and the weird little quirks in the specific data it saw.
This slide really shows you the two extremes. The overfitted model on the left, that's like a student who just memorized the answers to one specific practice exam. Yeah, they'll get a perfect score on that exam, but they're going to completely bomb the real test because they can't handle any new questions. What you really want is the model on the right, one that actually learns the subject, that can generalize its knowledge to new, unseen problems.
That ability to generalize, that is the true test of any machine learning model.
So, once you master this process, once you know how to build a model that actually generalizes, what can you build? Let's take a quick jump to the AI frontier and see where this all leads.
One of the most incredible applications is deep computer vision. We are literally teaching machines how to see and understand the visual world. This is the tech behind everything from unlocking your phone with your face to self-driving cars, navigating a busy street.
And then there's natural language processing, or NLP. This is all about getting machines to understand us, to understand human language. It's what powers things like real-time translation and those chatbots that are getting scarily good at holding a conversation.
And it gets even more creative. We now have what are called generative models. These are AIs that can create brand new stuff from scratch. We're talking about tools that can whip up a photorealistic image from just a text description or even compose a piece of music. It's really pushing the boundaries of what we thought was possible.
Now, to put all this into perspective, the AI pioneer Yann LeCun offered this incredible analogy. He said that if intelligence was a cake, then supervised learning, the thing we've mostly talked about today, the thing that powers so many of these breakthroughs, is really just the icing. The bulk of intelligence, he argues, the actual cake itself, might be in unsupervised learning.
And that leaves us with one last really fascinating question to think about. If all these amazing technologies we're seeing today are just the decorative topping, what does the whole cake of intelligence even look like? What kind of new frontiers are we going to unlock when we finally figure out how to bake it? It's a pretty powerful thought for the future of intelligence, both artificial and our own.